To study a particular biomolecule, you first need to isolate it from the mixture of molecules in your sample. But how do you separate your desired molecule from that mixture? Affinity chromatography is one of the most powerful methods of isolating a biomolecule from a sample. It exploits the selective and reversible binding of molecules occurring in many biological interactions. The method requires a mobile and a stationary phase. The mobile phase describes the sample solution in which your target biomolecule is solved. The stationary phase encompasses a chemically inert surface made from the ligand, the core, and most of the time, the spacer. The ligand is the component that the target biomolecule has an affinity with. These affinities occur between interaction partners such as enzymes and substrates, antibodies and antigens, or hormones and receptors. Various tags can also be added to biomolecules to create such an affinity. Between the core and the ligand, you will find a spacer. Typically, the spacer contains a hydrocarbon chain that can vary in length depending on its chemical origin. The longer the spacer, the higher its mobility. The core can be composed of agarose, silica gel, aluminium oxide, acrylate, or organic polymers. To illuminate what affinity chromatography looks like in practice, we will use the purification of His-tagged proteins as an example. This kind of purification is usually reached by immobilized metal affinity chromatography, or in short, IMAC. Typically, the stationary phase during IMAC is made from agarose beads, and the ligand could be NTA that is coupled to a metal ion. The metal ion should be chosen wisely as it impacts the balance between affinity and specificity of the purification. Higher affinity can generate a greater yield of biomolecules. However, this comes at a cost because it reduces the binding specificity. The lower the binding specificity, the more likely it becomes that you find unwanted biomolecules in your eluate. To execute the chromatography, the stationary phase can be packed into a column. The mobile phase, containing the His-tagged protein, is added to it. During incubation, the His-tag binds to the NTA metal ion complex. Afterward, the column is opened and all molecules that did not bind to the immobilized ligand are washed away by a buffer. Lastly, the His-tagged protein must be detached from the ligand so that it can be eluted from the column. This is often done via the competitive binding of imidazole. Among the chromatography techniques, affinity chromatography plays a major role because it is highly specific, effective, and widely applicable. Separating target biomolecules from a sample is the first step of discovering their structure and functionality, and allows us to explore the inner mechanisms of life.